Okay, we're going to do a problem of mechanical energy. Okay, mechanical energy. And we have the total energy. The total mechanical energy is going to be the summation of the kinetic energy plus the potential energy. So this would be our formula right here, which is kinetic energy plus potential energy. So let's say that we have here a little building, and here is our little building right here. Okay, and this would be the floor over here. This would be the height. Okay, this would be the height of your building. And then you have a box over here at the top, a little box. Let's call this the height. This would be the height of your building right here. This would be H, and the point right here at the middle. Let's do this one right here at the middle. This is going to be, this point is going to be H divided by 2. And over here at the bottom, this point here is going to be H equal to 0. This is going to be H over here. And this would be your box. And the box is at rest. So the initial velocity is going to be equal to 0 because it's not moving. And then you're going to let it go. You're going to let it go, and it's going to start to fall down this path right here. Let's give it another color. It's going to start to fall down this path here. And then you want to know what is the velocity when it reaches right here, this point here. So you want to know what is the velocity at h divided by 2. And then it's going to continue coming down this way, and you want to find what is the velocity over here, the velocity when h is equal to 0. You want to find out what's the velocity there. Okay, so the total energy is going to be, okay, we're going to give the mass of 10 kilograms. And we know that G is 9.8, more or less 10 meters over second square. Okay, and the height is going to be equal to 10 meters. Okay, so let's see what happens here. So the total energy is going to be equal to 1/2. I'll do it right here. The total energy is going to be 1/2 of the mass velocity to the square plus mgh, which is the potential energy. But the velocity is going to be 0 because it's the initial velocity. So all this term is going to cancel out to 0. So you have your total energy is going to be, that's at the top. At the top, your total energy, before you let the box move, before you let it go down, the velocity is going to be 0. So it's going to be mgh. And that would be the total energy. So then you release your box and you let it come down. And at the half of the path here at the half, we want to know what the velocity is. Okay, so we have that the total energy is mgh, and that's going to be equal to 1/2 of the mass velocity to the square. And we want the velocity at h divided by 2. That's where we're looking for the velocity. And this is going to be plus mg h divided by 2. H divided by 2, because that's the new height. That's the new height. So you can send this guy to the other side. So it's going to be mgh minus mgh divided by 2 is going to be equal to 1/2 of the mass velocity at h over 2 to the square. And you can put a 2 over 2 right here. So 2 over 2 minus 1 over 2 is going to give you 1 over 2 mgh is going to be equal to 1 over 2 m v to the square of h over 2. Okay. So you can get rid of the 1 over 2 and the 1 over 2 and the masses and the masses. So g times h square root is going to be equal to the velocity at h divided by 2. So you can calculate that one. So it's going to be 10 meters per second square times the height, which is 10 meters. And you got to get the square root of all this. So this is going to be equal to 10 meters over second, 10 meters over second. And that's the velocity that you're going to get at the middle of the trip. Okay. And now we have to get the velocity at the end. So when you reach the floor over here, because your box is going to pass through this point, and then it's going to land over here at the floor. So when it lands at the floor, you want to know what is the velocity before it hits the floor. Okay, so we do have that the total energy is going to be mgh. That's the total energy, and that's the energy you calculated when your box was at the top, over here at the top. You calculated the total energy as mgh right here. But now you want to know what happened to that potential energy. Well, it has been converted into kinetic energy. And now it's going to be 1/2 of the mass velocity when h is equal to 0 to the square. So what's going on here? What's going on is that all the energy that at the beginning was potential energy now has been converted into kinetic energy, because all the potential energy has gone away. But where has it gone? Well, it has gone to be converted into kinetic energy, and that's why the box is moving faster and faster. So you can cancel the mass with the mass, and then you have that 2gh square root is going to give you your velocity when h is equal to 0. And you can calculate all these guys. So this one is going to be the square root of 2 times the square root of 10 times 10. I'll skip the units for now. And that's going to be the square root of 2 times 10 meters over second. So you got your velocity at the end of the trip when the box is going to hit the floor. And you can also see this like a transfer of potential energy into kinetic energy. For example, in point A, okay, let's call these, let's give them names. Let's call this point A. Let's call this point B. And let's call this point C. So what's going on? So let's see. In point A, this is right here. We have that, let's do the 3. Here we go. We're going to do another one right here. And we're going to do another one over here to show what happened to the energy. Because this is a typical example where the energy has been converted. So it's going to be, I'll make a little box here to put all the energy inside the box here. And another one over here. So this is a case where the energy has been converted. All the energy has been converted from potential energy into kinetic energy. Here is our little box right here. Okay, so we got this one right here. And then we got another one over here, more or less. Okay, get this here, right here. We got another little box here, so we can see how it has been converted. Okay, and then here we go. Well, this one should be a little bigger. Okay, let me just do it like this to make it a little faster here. So, okay, we got this one right here. I'll just do it a little faster here. So here you got the kinetic energy and the potential energy, kinetic energy and the potential energy, kinetic energy and the potential energy. So in point A, all the energy is potential, all the energy is potential. And then as the box starts to move and fall down, as the box is let go, you let it go, and then it starts to go down with velocity, and the velocity is increasing. At point B, which is at the middle, what do you have? Well, this energy, all this energy here, it's going to be mgh. And over here, half of it is going to be here. And the other half is going to be here, the other half. But if you add them up, in point B, if you add up all the potential energy plus the kinetic energy, it has to be equal to this one over here. And then over here in C, all the energy has turned into kinetic energy. So you can do this diagram over here. So where has all the energy gone? Well, it has been converted into kinetic energy. And that's how you go from potential energy to kinetic energy in a gravitational system in which the energy is conservative. And we call the energy conservative because the total energy is always constant. The total energy is going to be always mgh, but you can switch it around into kinetic energy and potential energy. And there you go. You have another problem related with energy. Thank you.